Hello dear friends, today we discuss the derivative of implicit functions. Now friends, for the implicit functions, one thing you remember that these type of questions will be a mixture in which you won't be able to discuss any formulae separately. For example, we start with this example. See, in this question we have x plus y equals to pi, then find dy upon dx. Now here we need to find the derivative of y with respect to x, but as you see these are mixed combination type questions. So for such type of questions in which no one particular formula is used, we use the implicit method in which we differentiate the left hand side and the right hand side with respect to the required variable. Now here in the question we need to find the derivative with respect to x. Just note, the derivative is with respect to x, so on the both sides you will differentiate with respect to x. Now solution, on the left side we have x, so we write derivative of x with respect to x, that is dx upon dx, plus derivative of y with respect to dx, that is dy by dx, equals to derivative of pi with respect to x, that is d pi by dx. I hope you got the point that we need to differentiate both the sides with respect to x. Now, so it becomes dx upon dx becomes 1 plus dy by dx equals to 0. Why 0? Because pi is a constant, and you remember the derivative of a constant function is always 0. So you get 1 plus dy upon dx equal to 0, and as you need only dy by dx, so you keep the terms of dy by dx on the left side and bring all the terms to the right side. So it becomes dy upon dx equals to minus 1. So this is the end of this question. In this way we will find the solutions. Now let us take another example, it will be more clear. See, in this question we have y plus sin y equals to cos x. This is again a mixture of variables and no particular formula can be applied, so we used the implicit function derivative formula so that it may be solved. Now again we need to find dy by dx. That means we will differentiate both the sides, that is the left side and the right side, with respect to x. So again apply this. So you get derivative of y with respect to x, that is dy by dx, plus derivative of sin y with respect to x, that is ddx of sin y, equals to derivative of cos x with respect to x, that is ddx of cos x. Now dy upon dx as it is, plus derivative of sin y. See, you remember the derivative of sin x was cos x, but here this is not cos x, this is y. So the derivative of sin y becomes cos y into derivative of y with respect to x, derivative of y with respect to x. Got the point? I repeat, the derivative of sin y is cos y into derivative of y with respect to x, equals to derivative of cos x is minus sin x, as you remember by the formula. So finally we get dy by dx plus cos y into dy by dx equals to minus sin x. Now again we need to find dy by dx. So the terms of dy by dx are put together. In the bracket we get dy by dx into 1 plus cos y equals to minus sin x, and take these terms to the denominator, we get the dy by dx term. So we get final answer, that is dy upon dx equals to minus sin x upon 1 plus cos y. See, this is so easy. Just differentiate both the sides with respect to x and you get the further steps. I hope it is clear to you. To make it more clear, let us take another example. This is sin square x plus cos square y equals to 1. Again, this is a mixture and we need to find the derivative of y with respect to x. So using the implicit differentiation, differentiate sin square x with respect to x. Again, plus differentiate cos square x with respect to x equals to differentiate 1 with respect to x, means differentiate both the sides, left side and right side, with respect to x. Now for the derivative of sin square x, you remember, bring the part to the left and you get 2 sin x into derivative of sin x. Again, for the derivative of cos square y, it becomes 2 cos y into derivative of cos y equals to, the derivative of 1 is 0 because 1 is a constant function and the derivative of constant function is always 0. Again, further solving, we get 2 sin x into, now the derivative of sin x is cos x, so this is 2 sin x cos x plus 2 cos y into derivative of cos y. The derivative of cos y is minus sin y into derivative of y with respect to x equals to 0. So finally it becomes 2 sin x cos x plus 2 cos y into minus sin y into derivative of y with respect to x equals to 0. Now we write only the dy by dx term on the left side and take all other terms to the right sides. So on the left we write minus 2 cos y sin y dy upon dx equal to, on the right side is minus 2 sin x cos x. So minus 2 and minus 2 cancel out and you are left with dy by dx equal to sin x cos x upon sin y cos y. Taking it further, take another example. I hope you will do it yourself, try by yourself. This is the question: x cube plus x square y plus xy square plus y cube equals to 81. Quite a mixture, na? So we apply the implicit differentiation here. For this, again differentiate both sides with respect to x. So x cube, the differentiation becomes 3x square plus, now for x square y, because these are two variables which are x and y, and you remember the product rule, the UV rule, so it will be derivative of x square y, the product of two functions x square and y. Again plus derivative of the two functions x into y square plus the derivative of y cube is 3y square into dy by dx equals to the derivative of 81, that is 0 because 81 is a constant function. Now 3x square plus derivative of x square y. For x square y it becomes the derivative of x square into dy by dx, u into derivative of v plus v into derivative of u. So it is x square dy by dx plus y into derivative of x square. And for the next term means the derivative of xy square, we will write x into derivative of y square plus y square into derivative of x plus 3y square into dy by dx equals to 0. So it becomes, on further solving, we get 3x square plus x square dy upon dx plus 2xy plus 2xy dy by dx plus y square plus 3y square into dy by dx equal to 0. Now again keep the terms on the left sides which have dy upon dx and take all other terms to the right side. So on the left side we are left with x square plus 2xy plus 3y square, with all of them having dy by dx as common, equals to right side we get minus bracket 3x square plus 2xy plus y square bracket close, and finally we get dy upon dx equals to minus in the bracket 3x square plus 2xy plus y square upon x square plus 2xy plus 3y square. So this is how you solve the functions using the implicit function differentiation. One thing you must remember, that you differentiate with respect to the variable whichever is in the question. If it is with respect to x, then differentiate with respect to x, that is dy upon dx, and if it is with respect to t, then dy upon dt, and so on. So friends, this is all for today. I hope you liked it. I hope you will share, like and subscribe. See you in the next video. Bye bye.